Hey everyone, it's Ryan with NCBPA. We are in Raleigh today on a Saturday for an open house for the first passive house of a series being built here by Will Alphin and his team from REdesign.build. We're here to tour them, check them out, learn about them, learn why they decided to build passive house, how they're going to be marketing them, who their target client is, and what subs worked on it, and just kind of how the construction process is going. So they've got about 4 of these that are going to be planned. This one's open for today, and we're going to go check it out. Come along with the tour.
Hi, my name's Will Alphin. I've been a builder in the Raleigh area for over 20 years. I have a degree in architecture from NCSU College of Design, and that's where I started my journey on learning about sustainability and my interest in architecture and construction. So we're building a probably an unusual thing in that it's a Passive House International, hopefully certified project, but we're also building it as a speculative project. So we haven't started marketing it yet, but this will be a for sale house. It comes in at about 3,500 square feet. Historically, most of my career, I've worked for clients. So we're commissioned to do projects, design-build projects. We started having a conversation about, gosh, wouldn't it be fun if we didn't have to handhold a client throughout the whole process? What if we designed what we thought was the right thing to do and then put it on the market and see if we could find a buyer? We've always been into sustainability and green building my entire career, essentially. And Passive House, I think, is the logical extension of that. It's sort of the next generation. Dylan, who works for us, is a Passive House consultant, and so he was a key player in sort of pushing me in that direction. And part of what I like about it from a marketability perspective is no one is doing anything like this on as a for sale product. So we have the market all to ourselves, right? And so we only need one buyer. We're not competing with an average house amongst other average houses. So I think we'll find our buyer, and then we've got 3 more lots that we'll do after that with the same Passive House product. When I first started thinking about that and getting involved in this industry, it was a passive solar house. That was sort of the thing. A lot of misunderstanding at that time in the late 80s of what was the right passive strategy or solar strategies for our region. So you see a lot of things that really belong in the Southwest, here in this area. But most of those houses were done in rural areas. So people were cutting in new roads, cutting out forests to create a southern exposure, and somehow that didn't ring true to me, because I think part of what sustainability revolves around is using existing infrastructure, using existing buildings, density for transit reasons. It's been a big challenge. I mean, it really has. Part of our strategy was acknowledging that in the beginning and knowing that, and that's why we have 4 projects and they're relatively identical. And so we thought, let's build one first. Let's learn everything we hopefully need to learn during that process, and then let's replicate that 3 more times and hopefully gain back some of that learning curve and put some economy into the whole project and some efficiency into the whole project by what we learned on the first one. So in some ways we're paying tuition, for this on this project, learning how to do this, but we're that's part of our mission statement. That's part of what we do. That's part of what we're willing to do. So I think it's a reflection of the architecture matching the technology of the house. It doesn't just look new and shiny and technologically advanced. It is technologically advanced. But I don't think that advancement is the thing that makes someone feel like they're at home, right? So I think the good design is that, and then I think the Passive House lends to that because we know that passive houses are quieter. We know that the air quality is as good as you can possibly get, like probably better than outdoor air quality, because we can add filters for allergens, we can add special needs filters, charcoal filter, HEPA filter. So the indoor air quality, and these aren't things that people necessarily perceive immediately, but subconsciously, between the air quality and the light quality and the quietness, it's just there's going to be a feeling of solitude, a feeling of being at home, a feeling of being safe. So I think those characteristics and qualities are a very important thing about Passive House, and a lot of Passive House nerds get caught up talking about energy and numbers, and I think all those are obviously very important, and performance. Those are all very important, but I think Passive House recognizes that also the comfort and the quality of life is not a byproduct of that, but it's equal parts. I think it's really, it's a sales opportunity. It's just like, it's saying, I have a better product. It's a matter of recognizing that you have what we're calling a high performance home. And so it's recognizing the opportunity to tell someone that, hey, I'm going to deliver a better home for you, a home that you're going to be happier in. And then I would add to that there's a learning curve, right? So you just got to be willing to invest in that learning curve, acknowledge that the first one is probably going to be difficult, that the first one is going to cost more than the next one. Again, some of those experienced builders in New York who've done this a lot, I mean, they swore that as, by the third or fourth or fifth one that they had done, that the cost between what they normally did and a Passive House standard, it was a nominal difference, and their clients were demanding it.
Hey, my name is Dylan Buonfrisco with REdesign.build, and we're at the Tower Street Passive House in Raleigh, North Carolina. This project is going for Passive House International certification, as you can see, we created a pretty simple form here, and we've got a balloon framed construction with dense packed cellulose. The walls are about 9 1/4 inch deep, and our average R value in these exterior walls is about R35 and then R45 in the ceiling. In addition to the timber framed walls and floors and ceiling, we've got a superior wall foundation system, which we've also furred out on the interior and dense packed with cellulose. Our slab is insulated with high density Roxol, and that's 3 inches of continuous sub-slab insulation. So yeah, come on in. Everything is made airtight, and we are verifying this with a blower door test coming up shortly with Proclima air sealing tapes and membranes. This is our exterior membrane, and all of our exterior surfaces are going to have a rain screen or ventilation gap to maintain proper drying and ventilation of our facade and our sheathing. Here we are in the basement. You see we used I-joist framing for the floors, and you can see the interior LVL is our floor band, and if you notice that's inside of our wall cavity, or inside of our envelope. So we've balloon framed all our floors, and the LVL is hung off the interior of the foundation. And that just helps us create a better, more continuous, very pure layer of insulation. And we furred out these exterior walls about 1.5 inches and put on this Proclima Intello vapor variable membrane. We're dense packing this right now with cellulose, and for our energy model, this wall section is a little unique because it's both the superior wall, and then we furred it out and insulated with additional cellulose. So we've modeled this in Therm, which is a program made by InRel, to come up with the total average value of about R26, and these walls are below grade. Most of these walls are below grade, and they're about 6 feet below grade. So here we have a service cavity, and basically everything, all our mechanical services run inside of the airtight envelope, and that's to create an easy air sealing situation and to create a high quality insulation, and it's for ease of installation for the mechanical and electrical plumbing contractors. So this is an 1.5 gap, and then our finish goes on top of this. And so all our lighting goes back to a central DC load center, and basically what that does is it converts all the power for the LED lighting, which uses DC power at its end source. It converts at a very high efficiency rate and gives us a kind of clean distribution of that DC throughout the house. It's later on we can couple that system to solar direct or direct DC, and kind of expand our DC microgrid. So this band again is on the interior of the foundation, and our insulation is literally going down to the top of that of our foundation wall here, without any other plates or obstructions in the way. So now we're upstairs on the main floor. This is all the timber framed area of the house, and basically we balloon framed these walls using 9.5 or 9.25 by 3.5 inch glulam beams. We framed them on the deck and lifted them up with a lift all the way up to the roof, and then we hung our floor off the inside of that. And so that allowed us to create, again, that continuous, simple air control layer and vapor control layer. And as you see, we're just in the process of dense packing behind all this Intello. And then we've got our service cavity again, where you can see our electrician is running his services on the inside of this cavity to keep our airtight layer as clean as possible. So the mechanical design for this house, well, first of all, the envelope, I would say, is the biggest piece of the mechanical system in this house. Our goal was to reduce our loads as much as possible, and then to come up with a system that was as efficient as possible in supplying those small remaining loads. So our system is based on a hydronic heat pump chiller, and it provides heating, cooling, and dehumidification. It also has there's also a three-way valve that allows it to provide our hot water in both the heating and cooling season. So basically we've got a heat pump chiller, and it supplies hot or cold water to a small 19-gallon buffer tank, and then two Delta T pumps create a call for a hydronic recirculating air handler unit and a hydronic coil that is ducted in line with our Zender ERV. And so the ERV is it's doing a lot of different duties in this house. It is first and foremost providing fresh air ventilation, 100% HEPA filtered air, and that operates continuous at a low flow to maintain and monitor indoor air quality. It handles our direct exhaust bathroom exhaust and kitchen exhaust. And then we also have this hydronic coil in line with the supply duct. And so that coil and the pump there will be a call to that pump for heating, cooling, or dehumidification based on the supply air temperature after the ERV. So once it's gone through the heat exchange, which it does at about 84% efficiency and sensible energy, and 64% enthalpy exchange. Once it is post-exchange, it goes to a post-heating coil or post-cooling coil. And this will further dehumidify, cool, or heat the air as needed. And then the recirculating unit is really like a supplementary unit that is meant to pick up peak load. And it's also, this being a somewhat experimental project, you know, it's sized so that with a safety factor that, you know, to pick up for any unknowns that we might have. In the future houses that we'll be doing with the following 3 that we have planned, we're going to monitor the performance of the system and evaluate whether we can eliminate this second air handler or replace it with maybe a small number of ductless heads.
Mm-hmm.
You can see these Zender ducts going throughout the house. They're very small, and rather than running one big duct, which can be difficult to get through your structural members, we've run small multiple ducts that that go to one supply register or return register to kind of gang up and create the required flow at that spot. The windows that you're looking at right now face due south, and they are Awilux and Schuko windows, triple pane, all aluminum with a thermal break in the interior. The center of glass value for these windows is roughly R11, and the whole unit, the installed value, given our including or factoring in where we stuffed our Roxol insulation around the perimeter, half-inch gap. Our whole window installed value is about R7. So to put that in perspective, what I like to say is that, you know, if you look at typical residential construction where you have 2x framing, a 2x4 wall with a fiberglass bed in it, and blocking everywhere, and maybe triple studs and headers all over the place, these windows alone are basically matching what you're going to get your actual R value to be in that 2x4 wall. So this is facing due south, and we've got a 6 foot or 5'6" overhang with a optimized louvers in the overhang to get proper shading in the summer and to allow light in for solar heat gains in the winter. It's just basic passive solar design, and you know that is the backbone of passive house. Is the lineage of passive house is, you know, just basic passive solar design, orientation, using glazing wisely, and proper shading. Beyond that, we have air tightness, heat exchange ventilation, and super insulation. So you can see how we detailed all these windows with the Proclima Vanna tape, Fescon Vanna tape to our Intello, which we pack our cellulose behind. And we're creating an airtight layer on the inside and the outside. I like to use the strategy of having an airtight layer on the inside and the outside, because you really want to minimize your air movement and any kind of convective loops, any possibility of air movement inside of the wall, and also keep all your interior air as interior as possible and all your exterior air as exterior as possible. So we're sealing on the inside, and this also, for me, I find it easier to pass a blower door test with an interior air sealing strategy rather than an exterior one, because when you're operating the blower door and you're trying to find your leaks, you don't have to crawl up the side of the building, and you're not competing with the outdoor wind and air.
So
we're going to be blower door testing the next week or so.
Oh, wow.
And that's our preliminary pre-drywall blower door test.
Yep.
We want to make sure we get everything tight, and then we put the drywall up. Feel pretty happy about it, and then we have our final third-party blower door test for certification purposes, where we need to hit below 0.6 ACH plus or minus 50 pascals.
Yep. 2
types of water usage I'm thinking of. One is our hot water and water distribution, and the other would be like our stormwater, rainwater collection. We can start with the hot water distribution, which we have here. We've done a home run system with manifold and tried to use the minimal diameter PEX lines. So we're using 3/8 PEX wherever possible, where the fixtures permit and where our pressures permit. ensures that you're going to have the minimal amount of energy waste, of wasted hot water,
Right.
After you're done using that fixture. So you go and you wash your hands or wash your face in the morning, you turn on the hot water. You'll have to clear out the least amount of water to start receiving hot water. And you'll also leave the least amount of water after you're done, because whether you're insulating your pipes or not, that heat energy in those pipes it's gonna be lost.
Right.
Most likely before you use that tap again. And so we want to minimize those losses, and we do that by minimizing the volume of water in the pipe. So moving upstairs, you can see this whole north wall is, we don't have a lot of glazing in here, but we do have a continuous ribbon of north light coming in through the top. And something that's unique about these windows is this is a really interesting automated window system. It's called Tiptronic, and it's an internal motor, so it's completely concealed, and we like that to maintain our kind of super modern, slick design. And the window automation can be based on your interior and exterior temperatures and set points. So if your outdoor air is a favorable temperature and humidity, and the windows will open, and it can be manually overridden. But this also addresses the issue of user error and operability, in that a lot of times we have windows that get placed or designed in a high area that's not reachable, and they're operable. That's they a lot of times they've never been used, or no one thinks to use them because they're out of reach. So this kind of automates that and makes sure that the homeowners will be able to kind of have a worry-free, foolproof natural ventilation. You can see the Intello on the ceiling here. This is our cathedral ceiling, basically, or this is the surface of our structural joist. So we're dense packing this. They are 11 7/8 deep, and we've got a 1/2 inch firm across the bottom. We're dense packing this with cellulose, and on top of this roof, we've got our sheathing, and then our Solitex roof underlayment, and then on top of that, we've got a 3-inch airspace, and our finished roof is a Galvalume standing seam roof. So we really wanted to maintain that continuous airflow over the top, and make sure that both our roof sheathing, our underlayment, and our roofing material will have a lot of, as much ventilation as possible. We are planning for a minimum of 5 kilowatt system.
And you won't need a whole lot because it's passive house, and that's the point.
Right. That is the key point of putting efficiency in front of supply. I like to call this a demand side strategy, and the idea being that you reduce your demand as much as possible before you look to other ways that you can offset the impact of your supply. And the demand side strategy I think is super important, because when you save on the demand side, there's cascading savings. So you invest in your envelope and your HVAC system gets smaller. The solar panels that you need fewer of. You just need less stuff. And there's a cascading savings that can be a savings to both the builder, the homeowner, as well as the planet, in that we're reducing the amount of things that we need. We're never going to get to our carbon targets, our energy emission targets, just by trying to ramp up our solar production. We need to be efficient and reduce first. And it's a dollar towards efficiency goes a lot farther than a dollar towards production. So that's what we do. So every bedroom has a supply, and every bathroom and the kitchen and certain other spaces have a return. And this operates 24 hours a day, providing fresh, HEPA filtered, carbon filtered, optionally special allergen filters, the fresh air to the bedrooms, and exhausting it from the bathrooms. And then in each bathroom there's a boost switch that allows you to boost up the exhaust, or it actually boosts the whole system. When you need to, when you're showering, using the bathroom.
So you just flip a switch and it'll come on for 2 minutes or 3 minutes or whatever needs to be out for?
And this system can be ramped up, however you want. when there's, say you're having a party, having people over, and you want to increase the ventilation.
Yeah.
You can also ramp it way down. There's vacation mode, and you can, kind of customize those set points. So we install all these ducts, and then Zender comes out and they commission them. So they verify that you're getting the flow that you have designed in every room, and that the system is perfectly balanced. And that's a big component of the ventilation system, is that it's balanced. It doesn't create a pressurization or depressurization on the house, pulling in air through any leaks if we have any.
But it won't low volt because LEDs are low volt.